So today we have matrix. So let's go and study the matrix. So please, everyone, like feel free. You can open mic, talk anytime. I think Sermo have mic background noise. So if you join like have like background noise, maybe mute your mic. So the matrix, where we're gonna start. So first of all, it starts around town. Sorry, this one. So we're gonna start from this handbook. The subject is matrix, but I did a summary of it right here. I will share this link in the chat. So like in the handbook, before we jump to the essential question, they give us like some technique that we wanna be aware of. So during the technical interview, we can use this one of this technique or edge cases that we should be aware of. So right here, matrix is a two-dimensional array. It can be used to represent data in structured manner. For example, in game not TikTok. The board can be represented as a 3x3 matrix. So corner cases, these are usually extreme cases that you should consider when you're writing your code. For matrices, this could be an empty matrix, 1x1 matrix, or matrix with only one row or one column. Creating empty nx matrix. So this is one of technique that we might need to use during the problem that we're gonna face. For example, we have two problems here: set matrix 0 and spiral matrix. So one of technique we can use is sometimes you might need to create a new matrix of the same size as the original one, but fill with 0. This often used in dynamic programming problems or when you need to keep track of visited cell during a traversal. In Python, you can do this with a list comprehension. So this is like a short way to make a copy of matrix that's gonna give you the same dimension and it's gonna fill it with 0. Another technique is make like copying the matrix. If you need to create a copy of a matrix, you can do this with another list comprehension. So this one gonna copy the same matrix with the value, with everything. There's another technique is transposing a matrix. So you have matrix like this and you wanna like make it like this. So the row become columns and the columns become row. The transpose of a matrix is obtained by swapping its row with column. This is useful when you need to perform the same operation on row and column of a matrix. In Python, you can use the zip function with the unpacking operator star to transpose a matrix. So zip star matrix. Note that zip matrix return a list of tuples. If you want a list of lists, you can use list comprehension to convert the tuple to list. This one, okay. Remember, these techniques are fundamental to working with matrices in Python and are often used as building block for more complex operation. So let's be aware of this technique. So we have the first one. We can create a matrix, empty matrix, fill it with 0, or create same matrix. So we can like this is kind of the same technique to copy the matrix. And this one we can like flip rows and columns. Let's see if we can like apply this technique on the problem we have today. So the first problem is set matrix zeros. Okay, let me zoom a bit. Given an mxn integer matrix if an element is 0, set its entire row and column to 0. You must do it in place algorithm. Okay, let's see what is in place algorithm. What is in place algorithm? Short, simple. If someone know what is it, like you can, yes.
To fill the same matrix that they give you, don't create a new one. That's the meaning, in place. You don't have to make another one. So you return the same.
I think this is for space complexity sake, right?
Okay, this one?
About to take another matrix in space in PLD?
I'm not sure. So like, can you repeat that after someone? Like, is it like the data or something? Like the value inside the matrix?
So they give you the matrix, right?
Mm-hmm.
That's the one that you have to change. You don't make a new one.
Okay.
That's the meaning of in place. So if they give you an array, for example, or a variable, or you must change that variable, not make another one.
Okay, so like I need to return the same array that they give me, not like a copy of it.
Yeah.
Okay.
Yeah.
Okay.
If you make a copy, they will know. So
I see. Okay. So let's see this example. 1, 1, 1, 1. Okay, we have 0 here. Okay, give an mxn integer matrix. If an element is 0, its entire row and column become like 0. So if I have 0 here, it's gonna like make this one 0 and this one 0, like we have here. Okay, and here, if we have 0 here, it's gonna make this 0 and this 0. If we have 0 here, it's gonna make this 0 and this 0. Okay, let's see, let's brainstorm what you guys thinking idea or algorithm that we can make this work. Then we can see a video about this problem, see their explanation, the algorithm they use. But before we do that, let's try brainstorm and see what you guys think. I think a bit. Or maybe
sorry, can we see the question again? Can I see the question, please?
Yes.
I didn't see the question.
Okay, so the question is, if I give you this array and there is a 0 somewhere, you're gonna make that row, that column all 0 and the same row also 0.
Okay. Thank you.
So how we can do this? We can whiteboard, right?
I think the core idea is to find locations of this 0, each row, each column.
I think we had a similar problem in the.
Alex?
If you remember the island.
Yeah. Yeah, you're right.
Yeah, so
maybe something similar.
Like something similar. Yeah.
Can we take?
Yeah, you check. So, for example, they give you a cell in that matrix. Let's say, for example, a 2, 2. So you have to check the the left, if you have cells on the left, on the right, and also on the top and the bottom. Yeah, until you hit the boundaries. So the boundaries are the size of the matrix.
Okay, can you repeat that, please?
Which part?
Because I was writing in the chat, like
what I feel is if you see a zero, you need to keep track of the row and the column of that particular zero every time you are navigating through the elements. Just keep track of the row, the particular row you are on, and the particular column that you are on. So that's my idea.
So we have to go through all the cells, right?
Okay, I think we have something here that I didn't read. Is follow up. A straightforward solution using OMN space is probably a bad idea. A simple improvement use is M plus N space, but still not best solution. Could you devise a constant space solution? Can someone explain this? I think this one mean that we're gonna go through all array, or is that mean the copy?
Yeah, it's mentioned in the space, so it's you don't have to make a copy.
Okay, more idea. Okay, let's jump to this video and let's see how they're gonna explain it, and we can pause at some points and then we can continue from there or brainstorm, or if someone have a question can stop the video and we talk about.
Hey everyone.
By the way, Shaza, like your mic is very low. I don't know why.
Elements in the array, in the matrix. So
I do agree. I think we're gonna loop through the array.
Yeah, can you go back to that image?
This one.
Okay. So for example, if the first one is 0, so I have cleared that the first row and the first column, so I don't have to go through them. They are zeros. So I need to step like to the smallest matrix that starts from 0. Yeah, that one. Yeah. So somehow I need to move to the inner matrix, and so on. Yeah.
What about if we made copies? That because I'm not gonna lie, I don't understand this well. Is a straightforward solution using OMN space is probably a bad idea. When they say like OMN, what that mean is that mean like you made a copy of this and you work on it, like you go one by one, and if it is 0 you put 0 there, like all the rows. A simple improvement use OMN. Okay, let's ask ChatGPT or someone can make this clear. Let's see. I'm trying to solve matrix problem and I read this requirement, this note. I don't understand it. The note is discussing different approach to solve the matrix problem. with regard to space complexity. Let's break down the concept mentioned. OMN space solution. This refers to a solution that uses space proportional to the product of the number of row M and the number of column N in the matrix. If you have an MXN matrix, this one that we have, the space complexity is OMN, meaning that algorithm might use a separate data structure or array of size to store. Okay, so this is the copy, right? To store the intermediate or final result. Okay, so this is mean the copy technique, and they say it is probably a bad idea. Now, what is this one? This one is plus. This suggests an improvement over the first solution using space proportional to the sum of the number of rows and the number of columns in the matrix. Instead of using 2D array of size, this approach might utilize two separate arrays, one of row and one for column. Each size, okay, so this one is also an array, but what do you say? This approach might utilize two separate arrays. So two separate array, one for row, one for column. Okay, so instead of copying everything, we're gonna just copy the row and row, the row and column. This one like this. So basically, if like there is 0 here, if there's 0 here, that means all this is 0, and all this 0 of 0 here, it means this is all 0. So when I'm looping through this, I can just come back to here and put 0 or 1 or wherever. So if I found 0 here, I'm gonna go to this array right here. Okay, let's put it. Let's put it here. Like this. So I'm going. I found 0 here. I'm gonna go here and put 0, and this 0. I found 0 here. I go here and put 0, and here 0. Then I'm gonna loop through this one, this 2, and if I find 0 here, I'm gonna make all this 0. I find 0 here, I'm gonna make all this 0. Okay, so far this is what's so if you're watching this right now, something happened, and I pressed, I think, pause button or something, so there was like a part of PLD that didn't get recorded. So I'm gonna try to redesign what we saw in this part. So basically what we discuss is the solution for this task or this problem, and one of the case was like, okay, do we go one by one? Because if we go one by one, let's say we have this 0 right here, right? And let's say this is 1, and we go on 1, then 1, then 1, then 1, and then I find this one. That means I need to make all these lines 0 and this one 0, right? Now let's say I did make this one 0 and this one 0, this one 0, this one 0, this one 0. Now when I'm gonna, my position is here right now. So if I go to this right here, what the value that I'm gonna check? I find that the value is 0. That means I need to make this also 0 and this is also 0. In that case, all this table gonna be 0, right? Because the real value here is 1, but it is 0 because I changed it because this one was 0. So basically I can't change this zero's value because I need to go and read the real value or like the initial value, because if it was 1 there, this means I shouldn't change anything here. I will just change this case 0 because this one was 0. So going one by one and changing in real time is a problem, right? So there was the technique of copying this and make like another copy of this matrix, and this then when we go 1 0, so like let's say this is gonna be like fill with the ones, or like just this tree like all filled by ones, and when I find 0 here, I'm gonna make, for example, all this 0, right? So I'm changing the copy, not the real one. But we still, because the task they said let me go back to the description. They said something about this one. You must do it in place, which means we need to like make the changes in place. Like I don't have a return here. I'm not returning a new matrix. I'm making changes on this matrix, the same one, and we have some requirements like using OMN space and or it's probably a bad idea. So making a copy like this, it's gonna be space gonna be OMN, and this is a bad idea. There's other possible ways. A simple improvement from this one is use OM plus N space, but still not the best solution. So this one is like creating, as we saw, creating this array here, for example, in this array here, right? But it's still not a great idea. So we keep brainstorming. It was really interesting. I'm kinda sad that that it wasn't recorded. Ningasi had a genius idea. Is like, for example, here, if you see that we have this array right here, you see this space is empty. So we have this space that we don't use, so it's extra space. So his idea was like, let's do a hash table, right? So now we have this dictionary. We can set just the keys that we want, right? So when I'm going through this element, if I found 0 here, I simply go here and put, okay, I found 0 in index 0 for C, so I come 0. The value doesn't matter. The key is the important part. Okay, so 0 for the index 0, and 3 for the 0 for R here, and 3 for the colon. So this is hash table for colon, and this is hash table for the what is called rows. And I keep looping first time, right, all of them, and marking the zeros here, and then I will loop again over this, but this time each time I go here, I see if this index is exist here. So if I come here and I find, okay, 0 0 0 is it here, okay, it is here and it is here. That means this box gonna be what is called 0, and then I will go to this one. This is 0 1. Do I have 0 1? I don't have 0 1. So to make it easy, so 0 1, it should be right here, because 0 is error, right? When I say 0 1, I mean row 0 1 colon, so it should be like this. Now if I remove this, I have 0 0 2 2 yeah, so I have 0 0 2 2 and 3 in colon, 0 3, or yeah, 0 3. I can't say like, I can like, because this is a dictionary, I can't do like 0 here because I already have this key 0, right? So 0, 3, because 0, 3 here, and 2, 2. So this was our idea, and we coded in Let's Code. We did 2 solution submission. The first one, let me see. This is not our submission. This one, no, this one, 2 hours ago. No, sorry, not this one. This one, yeah. So 2 hash table right here. The length of the matrix, the row, the column, and then we loop through each element, and we just mark the hash table with 0 like we did here, and then we loop again to all the matrix, and we check if error in table like that index, we check if that, for example, 0 is in this 0 here, or 0 is here. So we check if error exists in table R and C in the table C. If it is one of them, or we just put 0 in that column. Yeah, and it worked perfectly. Then we watch the video that you're gonna watch now. Okay, sorry for this technical problem, and hope you guys enjoy this video. This is what I understand from this, and not the best solution. Do not imply that although the OMN plus N space solution is improvement over OMN, it might not be the most optimal. Any thoughts? What do you think? Jump to the video. Okay, let's see. Let's see.
Hey everyone, welcome back, and let's write some more neat code today. So today let's look at set matrix zeros. We are given an m by n matrix, and we want to go through every element. If we see that an element is 0, we're going to set the entire row and the entire column to 0. So for example, we're given a grid. There's only one 0, so what are we going to do? We're going to...
Oh, that, 1 second.
Set everything in the column. Column is going to be set to 0, and the row is going to be set to 0. So why can't we just do that in place? Like, why can't I just put a 0 here and then a 0 here and now a 0 here, right? Because there's actually a good reason, because so far we've checked off these spots. We checked off this spot. Now we're over here, right? But we replaced that 1 with a 0 now. So now we're going to end up making this a 0 and this a 0. But that's not really what we want to do. And that's the reason why we start off with a copy. So when we make changes, we're going to make changes to our copy. And when we read the values, we're going to read from our input. So remember, we did see a 0 over here. So in the copy, we are going to update the entire row. So this is going to be a 0. This is going to be a 0. So every value in the row, but we also have to do the column. We see this is already a 0, but this is going to be changed. So now we made changes to the copy. So this is a 0, but we see that this is still a 1, right? Because now when we go to the next position, which is this, we see it's a 1. So we don't actually have to modify this column and this row, right? Because we haven't even read this value yet. And now we're just going to continue. So this is the next position in our matrix. It's a 1, so we don't have to do anything. And this is the next one. It's a 0, so it's time to set the entire column to 0 and set the entire row to 0. So in our copy, we see that we actually already did this column. So this is kind of an example of the repeated work that we're having to do, right? It kind of shows you that maybe having a copy is not the best solution, but we still need to update the row. So we're going to change this to a 0 and we're going to change this to a 0. So next we go to this position. It's a 1. We don't have to do anything. And then we go to the next position. This is a 0, so it's time to make some changes. We're gonna set the entire column to 0, and we're gonna set the entire row to 0 in our copy. So we see that this is already a 0, so this is the only other value in the output that needs to be changed to 0. And we see that the column has already been set to 0. So clearly having a copy of the input array takes m by n memory, and it's also not the most time efficient algorithm either. So how can we do better? We're noticing for every single cell in our input, we're potentially having to update an entire row and an entire column. Can we prevent this repeated work? Yes, I'm going to show you how. So we see that we actually have a fixed amount of rows, right? Let's call that M. We have a fixed amount of columns N. So worst case scenario, all we're going to have to do is make sure that every row is set to 0 and then every column is set to 0. So as we iterate through every single value in our input, let's not update the copy. We actually don't need the copy. We need less memory. We can have one array for the number of columns and one array for the number of rows, and then we can mark these whether we want to fill in zeros or not, and then at the end we can actually fill in the zeros in our input array without even needing a copy. So let me show you this algorithm. So we have
Wait, so this is kind of like we did, right?
Yes, exactly.
He
Yes.
use arrays. Let's keep going.
Yeah,
Yes, he used arrays. We used the hash table.
a 1, so we don't have to do anything. So this empty indicates that we don't have to zero the row or the column. Next, we see a 0. So what are we going to do? Well, we're going to say, okay, in this column, we're going to fill it. We're going to fill it with 0. So this is some work that we have to do. In this row, we are going to fill it with zeros, but we're not going to do it yet because we don't want to overwrite this value that we haven't even visited yet. And we definitely don't want to overwrite this value yet, which we haven't visited yet. Next, we go to this position. It's a 1, so we don't have to do anything. This is also a 1. This is a 0, so technically we have to mark this spot, but we already did that. We already know this column is going to be set to 0, but we want to say that this row needs to be set to 0. We're not going to fill the zeros yet, but we're definitely going to mark it. So this is a 1, we don't do anything. This is a 0. We know that this column has to be set to 0, and this row has to be set to 0. Now, technically, we see that every row is going to be set to 0, so therefore, like, the entire matrix is just going to be 0, but we're still going to continue our algorithm. So this is a 1, we don't have to do anything. This is a 1, we don't have to do anything. So now what we're going to do is we're going to look at this memory, and it's going to tell us which columns need to be set to 0. So we see the first column does need to be set to 0. We're going to do that. The second column needs to be set to 0. We're going to do that. The third column does not need to be set to 0. Next, we look at the rows. The first row needs to be set to 0. We mostly already did that, but don't forget about this one. The second row is going to be set to 0. The third row is going to be set to 0. And obviously the entire matrix is now 0, but the advantage of this is the memory we used, we didn't need to create an entire copy, we just needed 2 arrays. So the memory complexity is actually big O m plus n, where these are the dimensions. The time complexity is m by n, because we're really just iterating over the entire matrix at most 3 times. One where we iterate through every position, one where we fill in the columns, and another time where we fill in the rows. And I didn't tell you the time complexity of this one, but it is actually greater than the time complexity of this. So this is actually a better time solution and a better memory solution. Now, my only question is, can we get a O of 1 memory solution? We know the best time complexity we can do is m by n, because we do have to iterate through every single position in the matrix, but we can save some space. Is it possible? Yes, I'm going to show you how. Is there a way where we can take this array and put it into the matrix so we can do this in place? Is that possible? If I put that over here, is it possible for us to take this array and put it into our matrix? The answer is yes. We can take these two arrays that we have and put them in our matrix. So we do this in place with O of 1 memory, but you see just one problem, right? Just one little problem. Notice how this position is overlapping. The two arrays are overlapping in this position, so we do need a tiny bit more memory. We just need one more cell, right? We just need one more variable, but we know that that's still big O of 1. So I'm actually, for the purple one, which tells us which rows we need to 0, I'm going to have it be one less. We don't want them to overlap. So we can get rid of this. We don't actually need the extra memory from these input arrays. We don't need this extra memory, but we do need this one single last cell because we see that there's no room for it over here. The green one took that from us. So you can see this is big O of 1 memory, right? We're just using one extra cell. That's constant memory. And so this is going to tell us whether we need to 0 out the first row or not. So
okay, so this is the magical way. Like you combine these places inside the matrix. That's kind of genius.
So now we're just going to run through the matrix for the third and last time. So this is a 1. We don't have to do anything. This is a 0. So what are we going to do? We're going to mark this cell. And how are we going to mark it? Well, we're going to set this to 0, which it already is, right? And we're going to set this to 0, indicating that this row needs to be zeroed out. This 0 tells us that this column needs to be zeroed out. Next, we go to this cell. It's a 1. Great. We don't have to do anything. This is a 1. Great. We don't have to do anything. This is a 0. So what are we going to do? Well, we're going to set this cell to 0 to indicate that this column needs to be zeroed out, but it's already 0. Good for us. But we also need to set this to 0 to tell us that this row needs to be zeroed out. And you see why this solution works, right? So now we're going to set this to 0, and that's okay for us because we already visited that cell. We already saw that it initially had a 1, so we can overwrite it. We're allowed to do that. The reason this works is we start at the top left over here and then work our way down, right? We start here and work our way top to bottom, left to right. So now we visit this cell, it's a 1, nothing to do. We visit this 0, so we got some work to do. We need to set this top value to 0 to indicate that this column needs to be zeroed out. And we need to set this position to 0 to indicate that the row needs to be zeroed out, but it's already 0, which is good for us. So now we get a 1, nothing to do. We get another 1, nothing to do. Okay, so now that we know which rows we need to zero out and we know which columns we have to zero out, so all we have to do is fill in those zeros. So we start here. We know this entire column needs to be 0. It already is. We know this column needs to be 0. It mostly is. We just have to change this last value. This is a 1, so we don't have to zero out this column. Next, let's go through the rows. So this row needs to be zeroed out, so we can change this to a 0. This row needs to be zeroed out, so we can change this to a 0. The third row also needs to be zeroed out, so we can change this to a 0. Now the entire thing is 0, which is the result that we expected. But the good thing about this solution is we did it in place. All we really needed was one extra variable. So with all that...
Oh, wait. Is that... Oh, okay. In place. So in place mean 01. So I see. So the moment you make a copy or you make an extra space, it doesn't become 01. Is that right?
Absolutely. So he just added one element in order to do everything. Wow.
See how we can
in place. All we really needed was one extra variable. So with all that being said, let's finally write the big O of one memory solution. So the first thing I'm just going to do is get the number of rows and columns and put them in some variables so we don't have to keep computing that. We can get the length of the matrix and get the length of the first row of the matrix, which tells us the number of columns. Remember, we don't need extra arrays, but we just need one extra variable to tell us if the first row is 0 or not. So initially, I'm going to set this to false to say that the first row is not 0, but we'll update it to true if we need to. So remember that the first thing we want to know is determine which rows and columns need to be zeroed. So we can iterate through every position in our cell. So we're going to go through every row and we're going to go through every column. If we ever find a value that is 0, in this case, if we find a 0, what are we going to do? We're going to set the first row, so row 0, in this column, we're going to set that value to 0. What we also want to do is in the first column, so column is 0, we want to set that row position to 0 as well, but just one catch, we cannot set that for the top leftmost position, so we're only going to do this if row is greater than 0, because remember, for row 0, we actually have a dedicated value, so if row 0 is greater than 0, then we do this, but otherwise, we're going to actually update this value, our Boolean. So we're going to set that to true. And so that's it. We're just marking which rows and columns to 0 out. So now the way I'm actually going to 0 them out is going to be a little bit different than how I showed in the picture. I'm actually going to go through every position one more time. So every row column pair. And I'm going to check for each position. So for this row column pair, do we need to 0 it out? And how do we know if we're going to 0 it out? Well, see up here, we would set the first row to 0. So if the first row value is 0,
sorry, Musif.
Yes.
This is approach and our approach. I think is there any much difference?
A lot. Yeah.
Huge difference.
He's using a two loop, right?
Yeah, but like the space, he didn't add
It's not about the loops, it's about the space.
Okay, the space. Okay, yeah.
Yeah, he had only 1 byte, which is crazy.
All right, I get. Thank you.
I think he did a mistake somewhere.
So know if we're going to 0 it out? Well, see up here, we would set the first row to 0. So if the first row value is 0, that means that we're
matrix OCR should be C. Okay.
We're going to 0 this out, but also...
Okay, because this is C.
If the column is 0, so if matrix of the first column of this row is equal to 0, then in either of these cases, we want to set the current position that we're at to 0. And so we cannot actually just do this by iterating through every row column. We have to actually skip the first row and we have to skip the first column because we're going to handle that after. So now that we...
Okay, so this first one, I should skip them. So I will only loop first to this, maybe later gonna come back to this one. Because if he like loop through them, that means he's gonna lose the value that it saved. Okay, that's really smart.
Is 0. So remember, the first row of the matrix tells us which columns we can zero out. So if this is equal to 0, that means we can set every value in our matrix in the first column. So I'm going to say column is 0. So if the first column in the first row is 0, then every value... So what we're doing here is basically zeroing out the first column of our matrix. And last but not least, we have to take a look at our last variable that we declared. So row 0, this tells us if we're going to zero out the first row. So if row 0 is true, meaning we have to zero out the first row, we're going to go through every value in the first row and zero it out. So matrix of the first row, row index 0, and every position in that row, we're gonna zero it out. So that's the algorithm. First we...
Wait, if it is 0, 0, okay, that's gonna zero the row. And if it is 0, 0.
No, if it's 0, 0, you're going to zero out the column.
Columns. Oh, column is fixed. Wait, error is changing. Okay, so it's going down. Okay,
Yes.
yeah, the column. Okay, and this one is going left or right. Okay, I see.
We determine which rows and columns to zero out. Then we zero out most of them. Then we zero out the first column if we need to. And lastly, we zero out the first row if we need to. And we don't have to return anything because we did this in place, which is what the problem wanted us to do. Okay, I'm so dumb. I don't know why I didn't finish this line of code. Don't forget to put this to 0.
So why didn't you test it? Let's be sure that his code is even working.
Okay, maybe he have it somewhere here. I don't think we can. We can actually. Can we? Maybe we can give
the first row and 0. That's the we
okay.
Zero out the...
There's a small chance this can work. It's like without writing the code. Where is it?
We can test it.
Okay, let me see. Yeah, it's really smart. Then if this to for loop, then to this equal 0. Okay, row 0.
Okay.
I think something is wrong, but let's test it first.
Yeah.
Maybe I missed something. Copying.
Yeah.
Here.
The index, the other index, it's not 0. I think you a circle. This circle at last.
Oh, what the?
Yeah.
Equal 0.
Yeah. Yeah, because it's not a condition.
Oh, no. One. Cool. Few seconds. Okay, let's wait a few seconds. Rows, line matrix, for error in a range. space first. Okay, so this should be here. 0, else row 0 true for in range 1 rows for in range matrix r equal. Okay, run. Matrix. Okay,
line 19, yeah. If matrix 0, and it should be column, not row.
Actually, it should be column. Yes.
Yes, that's it.
C.
And 923, the space between range and rows. Does that space not mean? There's a space 923.
Okay.
Can you repeat?
I was talking about the space between your line 23 where you defined
style.
R in range.
Oh.
No, you talk about the range between the range and the parenthesis.
Yeah.
Okay. Okay, it worked. It was great.
Yeah.
Nice.
Yeah.
Yes.
Check the space.
Let me submit it.
Yeah.
Maybe we can compare it with ours.
Yeah.
Okay, I think
ours is gonna be better.
Yeah, I think I pressed pause button, so part of this PLD didn't get recorded. I'm not sure which part, but what happened is we were solving these problems. Let me just do a quick rundown.
Okay.
So we were solving this set matrix 0 problem, and we were brainstorming the solution. Where is X draw? So first we were like, okay, we can use copy to copy this array, and then but it wasn't recommended. So we were like, okay, we can use array, one for the column, one for the row. Then we're gonna find out that we're gonna have spaces that's empty, and which Ningasi, sorry, I kill your name. Ningasi suggests we use hash table. Then we don't have that problem of like empty space. Ningasi, you wanna add something to it?
Yeah, no, that was just, we're just trying to reduce the amount of space that's used. So I thought a hash table would be more efficient in that you don't have to have empty element spaces. The n plus m dilemma with the space complexity.
So, and this worked perfectly. We tried, this is the code. Let me show you. Submitted, I think here, the first code or submission, 20 minutes, this one. So this is the code. It's lesser, it's shorter than this one. And we use 2 hash table. Now let's compare this one. Right. Okay. Compare this one. Where's Excalibur? So this is our solution. And this is the video solution. Let's see how to take more space. Wait, there's not big difference.
No, yours is better. Yeah.
Wait, ours is better, lol. Okay.
That's why.
Okay. So ours less space, and still like there's not that much. So the hash table is good. I think if we did use array, it's gonna be much larger.
Yeah.
Okay. And if someone misses the for them, like for the solution that the video suggests, he actually just kinda move this array here, move this array here. He had this problem here, this collapse. He creates a variable here that's gonna be responsible for column. I still have to do TypeScript project, so I will have to go. But you guys can continue the PLD. Shaza, if you wanna continue from here, or we can end here. It's up to you guys. Feel free. This is your space. Any question? Anything, please go ahead.
Let's take a break, please.
Yeah, but it was really fun. Okay, let's end it here. Shaza, you have something you want to say?
Thank you so much. And I'm so happy that we could, let's say, this whiteboarding almost solved the problem. We passed about 90% in whiteboarding of the solution, and this is very good. This is a new hit of our PLD, by the way.
Yeah, and thanks to Ningasi. Like I appreciate you so much, Ningasi.
Yeah.
Okay.
Oh yeah, one more thing.
Are
on the space complexity.
Are you sharing the video in the group after the session?
Yeah, it is in the. So the video that we watch is in the chat already. The PLD recording, I'm gonna put it in like as always. So if you go to PLD recording, so each session we do, there's video here, and announcements for like when is something happening. And by the way, if you wanna have idea, you wanna create event, you can just create events from here. And yeah, this is your server. Do whatever you want. If you need some permission, like you can send me DM, and I will give you permission that you want. Any question?
Please add the video of the solution of this guy. He is amazing to resources. Can we?
Yeah, to resources channel resource. Okay. Yeah. Okay. I will do it now.
Yeah. One more note, maybe on the space complexity thing. So like I think that the reason why we were stressed on, or it was insisted that we focus on getting an O of one space complexity is because we can imagine a situation where we're dealing with an extremely large data.
Yeah.
Wait, can you repeat that, please? I didn't hear.
You're dealing with large data set, a lot of values, like 10,000 rows, 10,000 columns.
Yeah.
You would have a situation where you need to process each and every row and column. So even if you still have to iterate through each and every cell, if you're trying to create a copy of the same item to then be able to process it, you realize you've escalated the situation dramatically. And one thing that you always need to remember, I don't know if you've seen the link, it was about numbers every programmer should know. It was about how long things take to run. So for example, you would have how long does it, so the way your computation works is you have your CPU, and then the CPU has its level cache, like low level fast access cache memory, right? That's like the fastest one to access. It was about 0.5 or something nanoseconds, and then to read from RAM is like 100 times slower. So if your solution is using O of n, you may not.
Hey everyone,
you may have an extremely fast solution on time complexity, but if your space complexity is not nice, you will have a situation where your CPU is running fast, but it has a bottleneck in the form of it has to wait for the data to be loaded from the RAM so that it can start processing. And loading from the RAM is way, way slow. It's like 100 times. I'll send the link for number they should know. So that's just something to think about. I hope it makes sense on why it was important to focus on reducing the space complexity.
Like, do you have the link for that? You said some article. Maybe share it with us. in research or chat. There's this that I want to share with you guys, and I forget. Is like a repo that have each company and the collection of lead code that they use in technical interview. For example, we can find here Facebook or like Google, and you can, for example, Twitter, and you can find the lead code that they use in their technical interview. So maybe if you're like,
sweet, bro.
wanna have like an idea what to expect or something.
Send the link, bro.
Yeah, it's in the chat.
Thank you so much, guys. This was a great session. I learned something.
Me too. I learned a lot. Thank you guys so much, and I hope see. So next session is Saturday. So if you still didn't have the Google Calendar, like you can find it in Welcome. It's gonna take you to the, like, just add it to your calendar, so you like have like notification PLD or we're gonna see linked list. Okay, it's gonna be fun. See you Saturday. Have a good day. Have a good night. Have a beautiful life. See you.
Right.
هلو
Hello.
مازال ما بديتيش تنت بحالي